Question 6, Wassce 2024 of the objectives. The volume of a cone is 264 cubic centimeter. If the base radius is 6 centimeters, find the height of the cone. Take pi is equal to 22/7. First of all, we need to know what a cone is. This is a classical example of a cone. This is a funnel. So this is a cone. At this point here is the apex or the vertex of the cone. A cone has a circular base. This base is a circle in nature. Okay, so this is an example. So a funnel is an example of a cone. Let's come to think of it. If you have this as the cone, a sketch of this as a cone, this is the apex of the cone, this is the altitude or the height of the cone. That's the h over here, that's the height of the cone. This is the circular base of the cone. So from the center here to the part of the circumference interior becomes the radius of the cone. So r is the radius of the circular base of the cone, and the L here is the slant height of the cone. I want us to actually look at some formulas that you could be asked in case you have not been asked this, to find the height of the cone, but any other thing is possible so far as Wassce is concerned. We looked at the curved surface area of a cone. The curved surface area of a cone, that's curved surface area of a cone. The curved surface area of a cone, that's when we talk about the curved surface area of a cone, we mean this part of the cone. That's the curved surface area when the cone is hollow. It is pi, then the radius of the cone multiplying the slant height of the cone. So the curved surface area of the cone is the radius of the cone or the circular base of the cone multiplying the slant height and that of the pi value. We can also be asked to calculate for the total surface area of the cone. Total surface area of the cone. The total surface area of the cone simply means that the cone here is closed. This part is closed. Here is hollow. When the part here is closed, then we can be able to work out for the total surface area of the cone. So it means that if this part is closed, we will have a circular base closed, which will have the area of a circle. So we have the curved surface area of the cone, which is this side, the curved surface area of the cone, plus the area of the circular base. So in all, we'll have pi r L plus r as the total surface area of a cone by factorization. You could also be asked of the volume of a cone as being stated here in the question. The volume of a cone is 1 divided by 3 pi r squared h. This is area of a circle, so the area of the circular base multiplying the height over here, so the area of the circular base multiplying the height of the cylinder, but not the slant height of the cylinder. 1/3 of that will give you the volume of the cone. So looking at this carefully, you see the volume of a cone. So the specific here, the volume of a cone is 264 cubic centimeter. So it means that we go indirectly pick the volume of a cone's formula so that we work out for the height that has been asked in the question. So we are looking for the height. Since volume has been given and the radius has also been given, we have also been awarded a pi. We need to calculate for the height of the cone or from the volumes formula. So let's look at solving the problem. We have been given in the question the volume of the cylinder. Volume of the cylinder has been given as 264 cubic centimeter. That's what has been given to us in the question. We have also been given the radius of the circular base, which is 6 centimeters. We have also been given the pi value as 22 divided by 7. So since volume has been given to us in the question, our interest is the height. our interest is the height. We employ the volume of a cone's formula to solve this problem. So the volume of a cone is 1 divided by 3 pi r squared h. That's the volume of a cone. So we input in the parameters given to us in the question. So we have the volume here as 264 is equal to 1/3 multiplying 22 divided by 7, multiplying the radius of the circular base of the cone, which is 6, squared of that, multiplying the height, which our interest is. So we have 264 is equal to, let's multiply the numerators here. 1 times 22 is 22 divided by 21, because 3 times 7 is 21, multiplying 36, multiplying the height. So 36 times h will give us 36h. We still have 264 equal to 22 times 36. I have 22 times 36, or multiplying 36. We have 792h, all divided by 21. Here is assumed to be over 1, so we cross multiply to obtain 792h is equal to the 21 multiplying 264. So 21 times 264, 21 times 264 gives us 5544. So we have 792h. We need the h, which is the height of the cone, 792 here divided by 792. So this cancels this, and we have the height of the cone to be 5,544 divided by 792. 792 have 7 centimeters as the height of the cone. So therefore, the height of the cone h is 7 centimeters. So from the question, the height of the cone, which our interest is to find, is 7 centimeters for the cone. So it may be A, B, C, D, depending on the paper you have at your disposal.